So in question number 6, which is coming from chapter 7, we're gonna do regression analysis. So in this question, we are gonna do a simple linear regression, and we're gonna do a quadratic regression equation. So simple and quadratic, but you have to make sure that you're ready for multiple regressions. When we have, so here we just have one, so it's going to be simple, but you have to be ready when we have multiple factors and when we have categorical variables. So you need to know how to create dummy variables for categorical variables, right? So that's the only thing. So let's go ahead and do these questions. So we first want to develop a scatter chart for this data and interpret the scatter chart basically. So let's go ahead and go to data file. So when we go to Q6 sheet, we have two variables, x and y. X and y. When we want to do a scatter chart, you have to make sure that x is your first column, right? So I'm gonna just move the column A to the right so that I have x and then y next to each to the right of it. So I just selected column A, Control X, which means I cut here, and then I'm gonna put it here. Right click, insert cut cell. So right, so now I have A and B. I have X and Y next to each other. So if I select both column and then go to insert scatter chart. So this would be my scatter. So let me just make it nicer a little bit. So let me just take this with me. Let's just go to the, let's just go here. So here is the answer to part 1, scatter, and then axis title, the horizontal would be X machine heat, and then vertical would be the number of defectives, right? dy. And then this one would be number of defectives versus machine heat. Okay. Now I have my scatter. So I can go ahead and add a trend line here. Add a trend line, and it would be also helpful if I show equation and r squared. So as you can see, I have, so the slope is positive. I see that it's increasing. There's a positive relationship. So I see a positive, I see a strong and positive. R squared is so big, it's 93% strong positive relationship between x and y, right? So that's part 1. Part 2, develop an estimated simple linear regression equation for the data. Put the output of the regression tool somewhere in this sheet and do not create new sheets, only type the equation here. Check the necessary conditions for statistical inference. Do you see any strong violation? If yes, which one is violated? So I'm gonna go back to my Excel file. So I'm gonna go ahead and use regression tool, data tab, data analysis, regression. So y range would be this number of defectives, x range would be the x machine heat, to column A1 to A110. So I check for labels because I started from the first row here. So I started from B1 and A1, and B1 and A1 contains text. So I check this one to exclude B1 and A1 from my sample. Then nothing else is necessary. I'm gonna put it in the same sheet. I'm gonna put it under part 2 here. Let me put it here actually, C23. And then for necessary conditions, I need to check residual plots. So that would be it. Okay. So this would be our table. This would be our regression analysis. The first thing I need to see would be to come up with to actually write down the equation. So this one, this would be my intercept, this would be the slope for machine heat. So my line would be y hat equal to minus 71.1 plus 4.6 heat, machine heat, or I can simply put x here. So this would be my linear equation, which if you look at your scatter chart, it should be exactly the same thing, because these two actually, this trend line and this regression tool, Excel regression tool, they both use least squared method. Least squared method for finding the linear equation. Now I need to check the necessary conditions. What is the condition that is not satisfied? So let me just go back here. So the ideal graph residual plots that I'm looking for would be residual xi. So what are the necessary conditions? The necessary conditions, we want to have residuals to follow a normal distribution with the mean of 0 and constant variance, and we also would like to see independently distributed, which means that they should show complete randomness. Okay, so at any range, normal means that we want to have equal numbers above and below. Normal means that the only way we can check for normal distribution is through symmetrical distribution. So it has to be symmetrical through the range of xi. This is our xi. So when you go from left to right at any small range, this should be normal, symmetrical, right? So you expect to have equal numbers of points above and below 0. Mean of error 0 means that the center of these bars should be 0 when you go from left to right. So this is cool. This is what I want to have. But if you at some range, if you have something like this, so in this range, in this neighborhood, it's symmetrical, but symmetrical around a positive mean, a positive error mean, right? It's still symmetrical around something, but that something, that mean, is not 0 anymore. So what the violation that is, why the actually condition that is violated here is the mean of error is not 0. And then constant variance is when we have this. Constant variance basically means that you have to have more or less the same variance as you go from left to right in each bar. So in this one compared to this one, compared to this one, compared to this one. But if you have like this type of thing, and then you see from this point onward, the variance, or you can actually use range also, is going up. So variance is not constant anymore from here to here, right? So but in from here to here, variance is more or less constant as you go from left to right. But from here to here, variance is increasing. So here this one is satisfied, here constant, we don't have a constant variance, here we have a constant. And then independent distribution. For independent distribution, we have to have residual versus time, or the order of selection. So with this one, it's really hard to see whether they're independently distributed. So we don't worry about this one now. So if we go back to our Excel file, now which condition is not satisfied? It's going to be variance is more or less the same. If you look at each bar, each small neighborhood of x, this is residual, more or less symmetrical, right, in each one. But then here we have error, mean of error here is positive, mean of error here is negative, and mean of error here is again positive. So it actually shows that. So checking necessary conditions. Mean of error is not equal to 0 at all, at the whole range of x. So this is violation, right? This is a violation. So that's it. And check the necessary. So that actually answers part 2 and 3 of question 6. So the last two parts, now develop a quadratic regression equation for the data and make sure that you identify the equation, and then you need to compare simple versus quadratic model, and you have to pick the one that you think is the best, and you have to justify your selection. So let me go back to my Excel file here. So now I need to run a quadratic. For quadratic, let me just go back to this one. So for quadratic, I should be looking for y hat equal to b0 plus b1 x plus b2 x squared. So I have number of defectives as my dependent variable, my y, and I have machine heat as my independent variable x, but I need to have another independent variable, heat squared, or x squared, heat squared basically, which would be these guys, machine heat to the second power. So the first one would be this power 2, and then I just need to repeat this for every single observation. So I just basically drag the formula down. I don't need these guys. Okay, you don't have to worry about it. It's not gonna, what actually is important is when you want to insert it in your regression tool. So let me go ahead and run it now. Data analysis, regression. So my Y range now, it won't be column B, it's going to be column C, C1 to C. C1 to C110, and my X range would be A1 to B. B110. And then everything is good except that I now want to put it in I can put it here. I don't have to move to the end. So I'm going to put it here. And then I make sure that I check for residual plot. And then this would be the answer to part 1, 2, 3, 4. Part 4 and part 4. So now what would be the equation? If I come here, look at the coefficient, my line would be y hat equal to 9.79, 9.8 minus 1.85x plus 0.1 x squared. This would be my quadratic line, and now I need to do the quadratic regression. So that would be my quadratic line. This is the answer to the fourth part. And for the fifth part, which model do you think is a better fit to the data? When we wanna, if you remember, when we wanna select the among different models, the way it works is that we actually compare them based on R squared, and adjusted would be better, and based on the number of significant factors, significant variables. So here we have a simple and we have a quadratic model. So let's go ahead and check there. So this one, the quadratic model actually gives a adjusted R square of 98%. 98, let me just check the other one too. 98, and the other one is 92 almost, I would say 92.5. So if I go back to my here, simple was 92%. This one was 98%. And then if I check the p-values, so in simple, in my second, actually in quadratic, in my simple regression, in simple regression, p-value here is lower than 5%. So we have one variable x, which is significant. So 1 out of 1 is significant. When we look at our quadratic model, we have two factors, x and x squared, and both are significant. P-value is lower than 5%, so both are significant. So here 1 out of 1 factor are significant. Here 2 out of 2 are significant. So now which one do you think is better? So indeed, when we move from simple to quadratic model, our R squared adjusted increases by 6%, and we actually increase one variable, which is indeed significant. So indeed, adding one more variable doesn't harm too much, but it actually increases our R square adjusted. So it explains variation in Y much better, by 6% actually. So therefore, I guess it would be logical to go ahead and select quadratic as a better model. So it's almost one, so it's perfect fit, and it's just one variable additional. So I'm just gonna go ahead, and so the answer to the fifth part would be quadratic model will be better because it provides better fit, which means higher adjusted R squared provides better fit, and both variables in the model are significant. So we don't have any insignificant factors in quadratic model. That's cool. That's something that we like. So merge and wrap. Right. So make sure that when you do something in your Excel file, make sure that it's easily visible, so that I can easily find it and I can give you your grade. So that would be the answer to question 6, and that would be it actually for our practice question.